Amin. Thank you banget semua udah join. Nah, pastinya masih pada semangat dong ikut webinarnya. Kita ada 1 hour session nih, stay tune terus sampai jam 9 ya. Nah, buat yang baru ikutan, jadi sesi ini adalah webinar kedua dari webinar series di Bootup, yang mana kamu bisa join secara gratis setiap 2 minggu loh. Gila, keren banget kan? Asik banget kan? Bisa join, bisa belajar bareng tentang data science, programming, AI. Nah, buat teman-teman yang belum tahu, aku mau memperkenalkan Bootup ke kalian dulu ya. Jadi, siapa sih Bootup Academy itu? Bootup Academy atau Bootup AI adalah sekolah coding dari Silicon Valley yang memiliki 4 pilihan program, yaitu Data Science, Artificial Intelligence, Machine Learning, dan Coding. Nah, kita juga punya beberapa kelas, yaitu dari kelas free webinar 1 jam ini, lalu kita punya kelas 6 jam, lalu kita ada kelas sebulan dan 6 bulan. Nah, Bootup sendiri adalah akselerator startup AI terkemuka, penyedia coworking space ternama, serta partner perusahaan berstandar global yang berpusat di Silicon Valley, Amerika Serikat. Visi kami adalah memberikan edukasi untuk kumpulan talent berbakat sesuai dengan kebutuhan industri teknologi seperti programming, data science, artificial intelligence, machine learning yang berfokus pada implementasi bisnis. Nah, Bootup Academy sendiri memberikan pelatihan bagi individu dan perusahaan, khususnya dalam menciptakan wirausaha hingga programmer yang berkualitas. Selain itu, Bootup juga menyediakan akses besar di dunia kerja, khususnya dengan para partner perusahaan dari grup Bootup di Amerika dan Indonesia loh. Tuh, ya, asik banget kan? Makanya nanti setelah kita ikut kelas webinarnya, coba kalian sign up di kelas 6 jam atau kelas 1 bulan dan 6 bulan ya. Nah, di webinar kali ini sebelumnya aku juga mau info ke teman-teman bahwa Mr. Halil berhalangan hadir untuk webinar kali ini guys. Maaf banget ya. Tapi jangan khawatir karena ada Mr. Anshu yang gak kalah expert loh. Siapa sih Mr. Anshu? Nah, our speaker is Mr. Anshu. He's an AI and machine learning expert from Bootup, Silicon Valley. Nah, his proven work record of delivering more than 100 workshops and technical training in various technologies and domains at the premier organizations, including IITs and other premier educational organization and corporate companies. Jadi, Mr. Anshus ini sama seperti Mr. Halil udah expert banget di industri artificial intelligence technology ini, data science, programming guys. Nah, today he's going to share some knowledge with us that will help you to become an expert in artificial intelligence. Mr. Anshu, welcome.
Thank you, Auntie. Thank you for the introduction.
Sure,
Hello,
sure.
everyone. I hope.
How are you, Mr. Anshu?
I'm good. Thank you for asking. I hope you're good.
Yeah, I'm great. Thank you.
Great.
Okay, I will.
So,
Yeah.
we will start.
Yeah, sure.
All right, everyone. So, very good evening and welcome you all to this webinar on Introduction to Artificial Intelligence. I will be talking about AI, machine learning, deep learning. We will be getting introduced to different terms in AI, machine learning, and deep learning. We'll be trying to understand the concept of AI, why to use AI, and which of the organizations are making utilization of artificial intelligence, machine learning, deep learning in different domain. We will also get to understand that if one has to become expert in machine learning, what should be the path? And we'll also be talking about the idea of computer vision and natural language processing. How is that related to AI? So let's get started. So first thing, when we talk about artificial intelligence, right? So as Wendy has already explained about who we are. So we are Bootup advisor and based in Silicon Valley. We provide education, world-class facilities to different organizations and learners across the world. And we have a big ecosystem of training experts, and worldwide we deliver trainings, educational services into a variety of domains. The topics that we will be covering up today includes artificial intelligence. We'll be getting introduced to that. We'll talk about computer vision. We'll talk about machine learning and deep learning, and then applications for the same. Let's get started. The first question could be, well, what exactly is artificial intelligence? What do you mean by AI? When we talk about AI, logically it is about providing intelligence to machines. When we say intelligence, what do you mean by it, right? So the idea of intelligence is building our own logic and following that and acting in an intelligent way rather than the rule-based system. Let's say if if we have to learn to ride bike, how to learn to ride bike. So if somebody says that you follow the rules, if this, do this, if this, do this, that kind of rules, right? So let's say that my father says that, okay, you're going to be following up this set of rules. If this, do this, right? If this and do this like that. Okay. If you get a traffic, put a brake or something like that, this sort of rules he says. The very first day, if he fixes some rules in my brain, I won't be capable of being expert in riding bike just by following those rules. I'll need to practice riding bike. I'll need to build my own rules of how to ride bike. I need to understand my own stimulus, the understanding that, well, this is how I will understand problems while riding bike. And we all develop our own rules, capability, understanding of how do we drive or ride bike. We all develop intelligent rules that we follow and we follow them. I mean, we do that in a much better way. In case we have to recognize our friends and family members, we also don't follow those if else rules. We don't follow the rules that if my brother's nose is very lengthy, he is my brother, or if my sister's eyes are very small, it's my sister, or big, then it's my sister, like that. We remember the pattern of faces of our friends and family members. We remember and interpret the pattern of speeches, their pitch of our friends and family members. We humans have capability to recognize patterns and develop our own rule-based system, or you can say logic, for performing different tasks, whether it is about recognizing faces, whether it is about speaking and understanding multiple languages, whether it is about riding bike, driving car. We develop our own capabilities from practice, from real world. That's what we call as intelligence. Nobody feeds these programs into our brain. We learn these things on our own, recognizing friends and family members, riding bike, driving car, remembering voice, languages, mathematics. We learn all this on our own by reading, by practicing. This is what we call as we have intelligent capability. When we provide this kind of capability to machines, computers, software, ERP solutions, CRM solutions, cars, could be any set of machine. we call that as artificial intelligence. So AI is all about making computers and machines act intelligently. Right? It's the science and engineering of making machines act intelligent, or you can say it's a science of and engineering of making intelligent machines. And in that intelligent machine, what actually makes it intelligent is the computer program running on that particular machine. So that's the understanding of AI, where we make computers, software act intelligently the way we humans act intelligently. That's what AI is. But the question could be, this sounds fascinating, but how do you do that? How do you actually make computers act intelligently, right? How do you make computers recognize faces? How do you make computers interpret speech? How do you make computers or software translate languages? So for this all, there have been a lot of development into artificial intelligence. There have been a lot of development in terms of development of mathematical algorithms to develop these intelligent capabilities. So over the years, since 1950s, even before that, there have been a lot of developments in terms of mathematical algorithms, testing, proving them, and analyzing their performance for, let's say, face recognition, for uh, speech recognition, for different set of capabilities. So technically, artificial intelligence is collection of those all algorithms which can be used to develop these intelligent capabilities, right? Which can be used to make computers think the way we humans think, right? Making computers learn from practice the way we humans learn from practice. So technically, artificial intelligence is collection of those all algorithms. So in early 1950s, it began the development under AI, and since then, there have been a number of algorithms developed for developing intelligent, for building intelligent capability. Out of all the AI algorithms, or you can say intelligent algorithms, so you can say artificial intelligence technically is collection of number of algorithms, right? So you can say technically it is collection of algorithms for building intelligent capability. And under AI, there are a bunch of algorithms. You can say it is more of an umbrella of algorithms which could be used for developing intelligent capability. Some of that algorithm I can use and develop face recognition system. One of the algorithm I can use to develop speech to text conversion system, or a chatbot, or a voice recognition algorithm, or a solution in banking or finance or healthcare, education or manufacturing. I can use an algorithm to predict the remaining useful lifetime of an asset of a car. We can use one of the algorithm out of AI to predict stock prices tomorrow, or weather forecasting. We can predict the sales that a company will be making in next 6 months, or how many customers will buy the product before even the release of the product. These are predictions of what will happen or whether this will happen or not. It's not possible with AI. So AI is a collection of such algorithms. Some of those algorithms are of AI, which are very powerful. And these algorithms consume data to build intelligence. And these all algorithms which consume data to build intelligent capability fall under machine learning. So machine learning is a subset of artificial intelligence, or you can say it's a part of AI, and is a collection of those algorithms which can be used to build intelligence, right? So you can say machine learning is uh, algorithms which consume data to build intelligent capability, right? So machine learning is a set of algorithms which uses data. So what is the difference between then non-machine learning algorithms and machine learning algorithms in the AI? So the non-machine learning algorithms do not make use of data. Then you can say all those algorithms of AI which use data fall under ML. Then there's another subset of AI which we call as deep learning. Deep learning are the set of even powerful algorithms under AI, under machine learning. You can say it is a subset of machine learning, which can also learn the algorithms which can learn what to learn. So deep learning algorithms are the one which can also learn what exactly they have to learn, right? So automated feature learning and plus pattern recognition is what deep learning algorithms can do. So these days, the set of advanced applications that we get to see, like self-driving cars, effective chatbots, the bank softwares detecting counterfeit notes, the advanced and accurate stock market predictions, the advanced optical character recognition, machine translation, many of these applications are backed by deep learning. So machine learning is a subset of AI. Deep learning is a subset of machine learning. That's the relationship between deep learning, machine learning, and artificial intelligence. When you talk about machine learning, we here say that, well, this is the collection of those algorithms which learn from data. Now, when you talk about data, right, let's say that when you talk about data, there are a number of fields where we have been utilizing data in different domain. There have been similar field called as data analytics. Right. So what we do into that? In data analytics, we generally work with data and we perform some statistically analyzed patterns, right? So what we do in that, so there is a concurrent field, you can say, in which we load data, clean data, and we perform some statistical and probabilistic analysis on data to interpret some patterns. Let's talk about an example. Let's say that we have a shoe manufacturing company in operational in Indonesia, right? A shoe manufacturing company is operational in Indonesia. And now we have to start selling shoes from the same company in Malaysia. If the company has to start with one of the shoe size and they want to make maximum sales, so what shoe size they should start selling in Malaysia? So for the question is that the business problem is we want to know that which shoe size they should start selling in Malaysia so as to attract maximum customers or to increase the sales. So we can say that, well, in that case, you can look at the data of the sales that the company has made in Indonesia. And from that data, we can calculate statistical mode. You might have heard about statistical mean, mode, median. So mode means the most frequently occurring value. So statistical mode can help that, okay, the shoe size, this is the shoe size which has been maximum sales have been made in Indonesia. So if you start selling that shoe size, probably you can make a lot of sales in initial days in Malaysia, right? So organization, businesses have been utilizing data and performing statistical and probabilistic analysis to interpret business patterns and take better business decisions. And that field is what we call is usually data analytics. And then data analytics improved up. And now if you talk about current definition of data analytics, it is more of a combination of statistical analysis plus machine learning, right? So this is what we call, the combination is what we call data analytics, right? So this combination, oh, it got erased. Let me try it again. Right, so they have been concurrent field where we have been performing statistically and probabilistic analysis. And the combined field is what we call as more of the combined field of statistical and probabilistic analysis plus machine learning, deep learning is what we call as data analytics. So in data analytics, we take the data, perform statistical analysis on that, and then we apply machine learning algorithms to develop a predictive model, right? So there are some questions. Let's say that using a priori algorithms are deep learning too? No. Is this real-time communication? Yes, we are in a real-time communication. Is data mining are part of AI? Well, yes, there are a number of machine learning techniques used in data mining. Okay, so that's the idea. All right. Well, so you see what we do in this part of data analytics is we apply some statistical and probabilistic analysis, and then we develop predictive model. Let me give an example to understand this much better. All right. So let me take you to one of the example of the banking data set. Okay, so let's say that there is a banking client and the bank has given us data of 10,000 customers. So we have data of 10,000 customers of a bank, as we can see that, right? And for every customer, what we have is we have row number of the customer, we have customer ID of the customer, we have surname of the customer, we have credit score of the customer. Credit score is usually calculated between 300 to 900. We have geography of the customer, where the customer belongs to. So this customer is from France. This customer is from Spain. This customer is from France. This is from France. This is from Spain. And this is from Germany. We have gender of the customer, right? So whether the customer is male or customer is female. We have age of the customer according to the document they would have submitted. Tenure. How many years it's been the customer is associated with the bank, that we have here. Balance. What was the minimum balance reported in the customer's bank account, that we have here. Number of products. How many products the customer has. One means probably, let's say, savings bank account only. 3 means savings bank account plus an insurance or a mortgage. Is it the customer has credit card or not? So one shows yes, customer has credit card. 0 shows no, customer doesn't have credit card. Then we have is active member. Is it customer an active member? Has customer done a lot of transactions or not? What is salary of customer? Estimated salary of that particular customer, right? So salary we have. Finally, the bank observed that in last 6 months, a number of customers started leaving the bank. So it shows that this customer has left the bank in last 6 months. This customer has not left the bank. This customer has left the bank. This customer has not left the bank. So on and so forth. Now the bank is worried. Why are the customers leaving the bank? As you can see that the bank is operational into multiple geographies, France, Spain, Germany. The bank is serving a big Age group, people of young age, old age, middle age, all are their customers. People of low credit score, high credit score, all are their customers. That means they are serving a big financial group as well. They're serving a big demographic group. They're serving two gender group, male and female. So all of them may have different reasons why are they leaving the bank. If the people kept on leaving the bank will get bankrupted, right? So the idea is what? They want to retain the existing customers. What we can do for them? As a data scientist or as a machine learning engineer, as an AI engineer, what we can do for them is first we can utilize this data, identify that why customers are leaving the bank. Tell them that, okay, these are the challenges that you have, why people are leaving the bank. Then we can use machine learning and develop an application out of this data. We can train an algorithm using this data, which can be used to predict in next 6 months out of existing customers who is more likely to leave the bank. If they know that in prior, they can provide that customer some relevant offers and retain the customers. That kind of solution could be a machine learning solution. Are we good so far, everyone? Let me know if the example is clear, right? I hope we are going good and good with the example. So initially we load the data, we perform a lot of analytics on this data to interpret this data, understand the domain, and once we are good with the analytics, we go ahead and build machine learning model if required. So these kind of challenges that we usually get in business, and we utilize the capability of AI, machine learning, data analytics to develop solutions and help the organizations grow, reduce their operations cost, improve their business margins and profits out of it. So there are multiple use cases where we can apply AI, machine learning, and businesses across the world have been growing up with those use cases. So that's the idea about the utilization of machine learning in data analytics domain. Right. So we'll see an example of how do we handle this particular problem. Right. Similarly, when we get data, when we talk about data, you can also say that, well, data could also be available in the form of text as well. So when the data is available in the form of text, what we do is we perform text processing. We perform text processing when data is available in the form of text or speech. And when you combine text processing or speech processing with machine learning, we call that particular field AI and machine learning, right? So we call that particular field as natural language processing. Similarly, data could also be available in the form of images as well, right? And when we work on images, we perform image processing, in which we talk about cleaning images, resizing them, removing noise, reshaping, extracting objects out of it. When you combine image processing plus machine learning, we call that field as computer vision. In computer vision, we develop applications related to face recognition, self-driving car, signature authentication, number plate recognition of vehicles. In NLP, we talk about applications like text recognition, chatbots, speech to text conversion, text to speech conversion. These set of applications we talk about in case of NLP. Right. Right. So that's the idea so far. I hope you're good with this. All right. So this is sort of stack of technology, how these technologies are related. Mainly AI machine learning is collection of algorithms. We use those algorithms in multiple formats. We use those algorithms in data analytics, in natural language processing, and also in computer vision as well. Let's go further. So now we can talk about what do you exactly mean by machine learning, right? So what do we exactly mean by machine learning? And what exactly are the applications of AI? So before that, if we talk about the applications of AI is used in varied domains. AI is used in financial predictions, predicting whether the customer will leave or not, stock prices, fraud detection, credit card fraud detection, player ranking in online games like PUBG and many of them, churn prediction, predicting customer will churn or not, customer behavior analysis. We use it in data mining. AI is used in data mining as well while working on web click data, medical records, and developing diagnostic systems. AI algorithms are also widely used, as we have seen in the previous slide, in computer vision applications like face recognition, fingerprint detection, the number plate recognition in vehicles, the signature authentication, bank note authentication, self-driving cars are number of applications of computer vision utilizing AI. We also use AI in NLP applications like voice recognition, handwriting recognition, sentiment analysis, chatbots, machine translation, and much of them. Other use cases of AI in different domain. In manufacturing, we use it for predictive maintenance, predicting that in what time the machine will get damaged or asset will not be workable, usable. We use it in retail for upsell and cross skill marketing and predictions. We use AI and machine learning in healthcare and life sciences for sentiment analysis for healthcare, disease identification, health management, alert generation, diagnostic generation. We use that in hospitality and travel, for aircraft scheduling, for fare calculation in Uber, and traffic pattern recognition, congestion management, in finance for risk analytics, churn prediction, sales market prediction, forecasting. There are a bunch of applications of AI in every domain, including energy, feedstock, and utilities as well. So these are very domain where AI is being used across the world and by a number of premier organizations. Other than that, if you talk further about AI, right, so we can further go ahead in terms of applications into computer vision. What exactly is computer vision? Well, we already discussed it's the subfield of AI where we talk about making machines capable of having vision like human, or the machines making machines capable of recognizing objects, detecting the objects, and generating text out of the video, recognizing images, generating caption of images from cameras and real time. That's what we call computer vision. As we discussed, the typical applications include self-driving cars, face recognition, emotion detection from images, fake video detection, the bank note authentication, like that. These are a bunch of applications of computer vision. Further, if we talk about the set of what we do in computer vision is, so we make the computers understand the images and videos, right? So what kind of scene is it? Where are the cars? And how far is the building? For example, you might have seen on Google, when you do Google search, let's say we search about a dog walking on the beach. Google search algorithm also fetch those images as well, in which even with the text associated with the image is not having these words, dog walking on beach, because the Google image recognition algorithm is capable of interpreting the content of image as well. So whenever we do Google search, we get almost right images, even if the text associated with image is not those words, is not containing those words. Then further, we'll talk about NLP. NLP is another subfield of AI where we talk about making computers communicate in human language. Very popular example could be Alexa, Siri. which are personal assistants. The other applications are chatbots, machine translation, text classification, search engines. NLP has seen a lot of recent advancements in terms of chatbots. A number of organizations, including the e-tailers, banks, sales support, tech support, have started adapting NLP solutions. There are a couple of subfields of NLP, like speech recognition, natural language understanding, natural language generation. Speech recognition is more of converting speech to text. Natural language understanding is making computers interpret the language, human language, understand the human language, or you can say making computers identify the intent from the content. And natural language generation is about making computers generate the content from the intent. That's the idea of NLP, which is another subfield of AI. Now, the most popular term, right, and awaited term, that is what exactly you mean by machine learning, right? And what exactly is machine learning? Well, that is machine learning is about making computers learn from data without performing explicit programming. Then you might have a question, what do you mean by explicit programming? So you see the way we have been developing systems, computers, software from last decades, we have been utilizing set of if-else rules. If this, do this, else if this, do this. That if-else rules, what we call explicit programming. The explicit mathematics like linear algebra, 2x plus 4y equal to 6z is an explicit mathematics, and that comes under explicit programming. So machine learning is making computers learn from data without doing explicit programming. This is an example of explicit programming. If these are the features F0, F1, F2, F3, F0, F1, F2, F3 could be age, salary, number of products, balance, geography, gender. So if we write if-else rules, if this, do this, if this, do this, else if this, do this, else if this, do this, this is not machine learning. This is not AI. This is uh, existing knowledge, right? The machine learning is more of black box model where we use algorithms, mathematical algorithms, and work on that and perform prediction. So here, the features do not have direct relation with the target. In between, there are algorithms from mathematics, like neural networks, like sorted to machine, linear regression, logistic regression, and all. These are very popular applications of machine learning, self-driving cars, the surveillance systems, political campaign management, optical character recognition, recommendation system on Netflix, movie recommendation, Amazon product recommendation, YouTube video recommendation, filtering news on Facebook, personal assistants. These are varied applications of machine learning. Then what's deep learning? A subset of that, a subfield of machine learning, or you can say subfield of AI as well. Deep learning, with deep learning, we mostly talk about images, text, and sound. We work with these kind of data. And deep here refers to neural network, right? So we use very deeper neural network to develop deep learning algorithms. The applications are self-driving car, the ATM rejecting counterfeit notes, smartphone giving the translation of foreign street. This is one of the difference between example showing difference between machine learning and deep learning. In machine learning, to an algorithm, we have to give extracted features. For example, if I have to develop an applications for vehicle classification, so we have to tell the algorithm that, okay, what is the height of the vehicle, what is the width of the vehicle, what is the sort of pattern of the vehicle, shape of the vehicle. Based on that, algorithm can learn that, well, how to recognize Maruti Suzuki, let's say how to recognize a Ferrari or a Mercedes or an Audi car, like that. But deep learning algorithms can do the feature extraction on its own. So deep learning algorithms are computationally expensive compared to machine learning. And deep learning algorithms require large data, but are far, far, far accurate than machine learning. Deep learning models are uh, slightly slow to learn. Machine learning models are quick to train. So that sort of difference is there between ML and DL. Okay, so why is AI important? Why do we talk about AI? So AI helps in automating repetitive tasks, making the complex systems more easier, making the computers learn from data and do the job in much effective manner compared to the human-based errors, and extracting more patterns out of the data, improving the business capability, improving the business efficiency from the data. That's why all the enterprises across the world are adopting AI in different solutions. How to learn machine learning and how to learn AI? Well, that's an interesting question you might be waiting for. What to learn in machine learning, how to learn this. So, well, the top of the iceberg, which is more of programming. So you need to learn one of the programming language, either Python or R programming, and then Spark integration of that with big data. So Python and R are the top programming languages in for developing a machine learning or AI solution. At Bootup, we have courses in that, both of them, and then machine learning mathematics, which includes probability theory, statistical analysis, and the linear algebra. If you try to even define it much more concretely, so you can say that the approach should be for learning machine learning. The first thing that we should go for is learning Python for machine learning. Then learning statistics. Learning statistical and mathematical analysis. Third is looking at the packages for machine learning. Fourth is maths behind machine learning. Right? This is the second one. This is the fourth one. Then practice, practice, and practice as much as possible. Then looking at optimization techniques, and finally handling big data. This is what we need to learn in machine learning, how in order to excel, in order to become AI expert or a machine learning expert. Right. So there are a variety of also cloud platforms these days coming up for developing machine learning solutions as well. These are a couple of very popular cloud platforms for developing the machine learning solutions and AI solutions. So Microsoft has Microsoft Azure ML Studio, AWS has AWS Machine Learning, SAP Leonardo, Google GCP ML platform, and IBM also has a machine learning platform for them. Right. So almost every organization you see is developing solution and a platform where people can do development. This shows that how much important AI is having in industry and how much people are interested into that. The opportunities possible with that are quite huge, right? The top programming languages are Python and R. Python is at most used programming language for developing AI or machine learning solutions. Right, so the very popular programming language used is Python, and then some people use R as well. Right, so that's the idea so far. So let me give you an example to understand the data analytics and also some example of machine learning as well. Right, here you go. Well, if I give you a clear idea about it, so let me ask you a question. Let's say that for this particular use case, if we have to develop an algorithm which can be used to predict whether the person will leave the bank or not. So if you have to feed this data to algorithm, so you see our target is to identify whether the person will leave or not leave, which is what exited. So out of all these properties, you see A is row number, customer ID, surname, credit score, geography, gender, age, tenure. Out of all these properties, which of the property you think that I should not feed this to the algorithm? This doesn't make any sense. Which of the column you think that is not related whether the customer will leave the bank or not leave the bank? Which of the column you think is not at all relevant? And we should not feed that as a part of data to a machine learning algorithm.
Name. Name.
So you can answer your question in chat box, or else there's a question box as well. In that you can put the answer. So out of this data, if I have to develop a machine learning solution, which column I should not feed? And you think that, well, this I think does not relate to whether the customer will leave or not leave. So out of these properties, let's say row number, customer ID, surname, credit score, geography, gender, age, which column you think that we can logically reject it and does not have any relation with whether the customer will actually leave the bank or not.
Should name.
So well, we have got answers here. That is surname, right? So I hope all of you agree with that answer. Surname has no logic, no relation with people will leave or not leave, right? So it is important, you see. I hope all of you agree on that. So you see, it is very important that we only feed relevant data to the algorithm. For the other features, let's say that geography or gender, how should I identify whether it is important or not? How should I identify whether gender is important or not? Or let's say geography is important for not. So let me give an example with this part, right? So let me take you to an example for this, right? So this is my Python programming interface,
Wow.
right? So if you are good with programming, if you're not new to, if you're very new to programming, at Bootup, we have a lot of programming courses to help people learn programming from scratch and become expert in programming, become expert in AI. So let's say I want to load that data here. Right, so I'll import some packages. Let's say right, so let me load the data. Df equals to pandas dot read csv, and I'm going to put here address of the file. So as we can see that now we have got data loaded here. This is our data loaded here. Row number, customer ID, surname, credit score, geography, so on and so forth up to exited column, right? Now let's say that we want to identify whether geography is impacting or not. So let me draw a graph here, and it's your turn to identify the pattern. All right, so here we go. Right, so I'm going to draw a graph here of geography, right? So and pld dot show. Well, so this data shows, this graph shows the overall customers of the bank. Okay. Now here, in which country bank has good roots? You think out of this graph, what do you observe? In which country bank has very good set of customers? We have just plotted the data of geography. As we have seen that we had geography, France, Spain, and Germany. So in which country we have very good set of customers the bank is having out of this graph? Right. I hope all of you would agree on that, well, it looks like France is having higher value, right? So bank seems to have very good set of customers in France. Now let's see that how many customers left the bank from France. So let me copy it and put it here. I'm going to attach a filter here. And see how many customers left the bank from France. So we'll draw both the graphs altogether. Now we have two graphs. The first one is showing the total customers and the second one is showing customers who left the bank. The first graph is showing the total customers and the second one is showing the customers who left the bank. So what do you think out of these two graphs? In which country do we have local challenges, or the bank is having local geographical challenges with the customers? The first graph shows the total customers, whereas the second graph shows the customers who left the bank from respective countries. So what do you think, in which country the bank has more geographical challenges? Right, so I'm waiting for your answers. Right, let's see that. It's pretty easy. You're gonna be able to do that. Well, so we have got a lot of answers here. Right, so I hope all of you agree. It looks like that, well, there is higher dropping rate in Germany, and the bank seems to have local challenges in Germany, and there are some local competitors. It could be probably the government rules there out, why people are more leaving the bank from Germany. So this sort of analysis that we do on data, then we take the data, clean it, and develop machine learning models to do prediction. So it looks a lot of interesting, and there are a number of interesting use cases that we take in trainings and educational programs at Bootup, and we make you work hands-on on this set of trainings, right? So that's idea about it. And so this is the whole idea about artificial intelligence, machine learning, a bit of data analytics and understanding. Well, there was a question that what is the difference between data analytics and data science? Are they same? No, they are not same. Data analytics is a subsection of data science. In data analytics, we mostly talk about structured numerical data, the business data, whereas data science is a very general purpose term. So data science also includes computer vision, natural language processing, and data analytics, everything into it. Data science is more about in whatever format you use data to help business grow, improve their efficiency, reduce their costs, reduce their losses. Either you're using image processing, you're using computer vision, you're using machine learning, you're using deep learning, you're using statistical analysis, or you're using text processing. So all these things comes under data science. Right, there's a question, how much data we need to build machine learning solutions? Well, as much as data we have, that much better performance we can get. So there is no mathematics to calculate the size of data, but at least we consider 100,000 observations to have good effective performing model, right? So 100 observations to 100,000 observations are minimum considered one, but in industry we usually have more than that even, right? So there's no mathematics, there's no threshold to say that the volume of data, usually as much as we have, that much better performance we can expect, right? So there's a question, how about if we have less data but we want to get a good prediction and classification? Well, there are some algorithms which work good on large volume data. There are some algorithms which work almost good on less volume of data as well. So we need to know which algorithm to choose in what scenario. And that's the art a data scientist needs to have. The understanding of algorithms and the capability of making decisions that which algorithm to use in what scenario. Then there's a question, how much data we must provide to get accurate deep learning result? Well, uh, deep learning algorithms needs a very good volume of data as much as possible. Again, there is no limit into that as well. But yes, deep learning requires heavy volume compared to machine learning. So uh, there is no mathematical limit, but yes, it should be as much as big possible. Right. So I hope that answers your question so far. everyone, Johanti and Ikshan, and all of you, everyone. Any question you have, let me know that. Any question you have, let me know. You can put that in question box. Right. So seems we are good so far. All right. Thank you all for joining the webinar today, and handing out to you, Wendy.
Hello, thank you for the knowledge, Mr. Anshu. Okay guys, so it's a wrap. Sayangnya kita harus mengakhiri webinarnya nih guys. Buat kamu yang tadi merasa ada miss-miss dikit karena nggak bisa dengar audio atau screen-nya, nggak usah khawatir karena nanti kita akan kirim recordnya ke email kamu kok. Nah, jadi guys, jika kalian tertarik untuk kelas yang lebih advance dan complete, silakan sign up di website kita ya. Nanti tim Bootup akan menghubungi kamu. Nah, untuk kelasnya sendiri terjangkau banget loh guys. Untuk kelas 6 jamnya aja mulai dari Rp299.000. Gila kan? Nah, untuk kelas flex dan immersifnya sendiri mulai dari Rp6.999.000 untuk 1 bulan hingga 6 bulan. Tapi nggak perlu khawatir karena kamu bisa cicil pembayarannya loh guys. Nah, pokoknya sign up sekarang, nanti kalau mau ada tanya-tanya apa atau diskusi, silakan banget, kita juga ada WhatsApp, call, email. Oke, nanti kalian bisa cek di social media Bootup atau di websitenya. Kapan lagi bisa belajar sama expert dari Silicon Valley langsung dengan harga terjangkau dan waktu yang fleksibel, setuju nggak? Okay guys, on behalf of Mr. Anshu as well as the team at Bootup, thank you for joining us and taking time to attend our webinar. My name is Windy. Have a good evening guys. Bye.